Let phi be an arbitrary smooth real valued scalar function and v vector be an arbitrary smooth vector valued function in a three-dimensional space. Which one of the following is an identity? So let's check all the options one by one. Option A, it says curl of phi v vector is equal to gradient of phi into divergence of v vector. Clearly this is incorrect because we know curl of phi into v vector is equal to phi, the scalar, times the curl of v vector plus the gradient of phi cross v vector. Okay, so option A is incorrect. Alright, now let's check option B. That says divergence of v is 0. Divergence of v is equal to 0. So this is also incorrect. Divergence of a vector field is 0 only when a point at which there is zero flux, okay, through an enclosed surface. Only that function will have zero divergence. Okay, usually it's a sink or source flow in a vector field, in a velocity field. Okay, now let's check option C. That says option C is divergence of curl of v vector is 0. So this option C is true because we can write for any vector field, we can write this as, okay, let's write here, dou by dou x, dou by dou y, dou by dou z, dou by dou x, dou by dou y, dou by dou z of some vx, vy, vz. And when we try to find the determinant of this matrix, this will always come out to be 0. This represent actually determinant. Okay, so this is always 0. So option C is correct. Now let's also check option D. Okay, option D says the divergence of phi v vector is equal to phi times the divergence of v vector. Okay, this is also incorrect because it is incomplete actually. Okay, so we know divergence from vector calculus. We can write this as phi times del dot v vector plus gradient of phi into v vector. Okay, so option C is the correct choice. This quantity is always 0. Divergence of curl of a vector field is always 0. So option C is the correct choice. For more information, you can refer to the NPTEL course Review of Vector Calculus, Gradient, Divergence and Curl Operators on Computational Electromagnetics by Professor Uday Khankhoje of the Department of Electrical Engineering at IIT Madras.